In the previous section, we have finished our algorithm. Now we are going to implement the animation that I have shown you in the previous video, so our map drops down in this stair-like manner. Let's create a new C# script. I called it drop twin. And let's open it up in our code editor. Here we will want to create a couple of variables, public static float, and we will call it time offset. Let's set it to 0. Public float scale time. This will be the basic time of the drop for our cells, and we can change it only through the script. We could expose it in a little bit different way, but for now let's leave it like this. Let's create vector3 destination. Great. Let's call start method, tab to create it, and we are going to set destination equals game object transform position. Now we are going to set game object transform position plus equals new vector3 0 10 0. So we are going to rise our game object 10 units above the position that we want it to be. We're going to set scale time plus equals time offset, and we are going to set time offset. After each creation, we are going to add to it 0.01 to set this effect so every cell drops a little bit later than the previous one. And we are going to start coroutine that we do not have, grow. Let's alt enter on this name. Hopefully we can generate it. Yes. And this will be not a string but I enumerator. I need to import using system collections. Okay, great. And this will be our coroutine that does all the animation. So vector3 position equals game object transform dot position float current time equals 0.0f. Now we are going to call do and call game object transform position equals vector3.lerp, and we're going to pass to it the position that we want to start from, the destination, so position that we want to reach, and current time divided by scale time. So we are going to move every interval a little bit closer to our goal, and we are going to add current time plus equals time dot delta time. And this will create the drop animation. We are going to call yield return null. So this will make breaks so that our coroutine works. And we are going to do it while our current time is less or equal to our scale time. After which, to avoid gaps between cells, between our tiles, between our prefabs, we are going to set game object, and I do not need those brackets. Finish the statement, and we are going to say game object dot transform dot position equals the destination to place it in the correct position, and basically that's it. So let's save it. And where we are going to use it? Well, actually that's not it, because we need two more methods: public static void increase drop time. So this will increase our drop time after every placement. We are going to increase our time offset plus equals 0.01 f, and we are going to create public static void reset time, because we have set it as the static variable. because we need to reset our time before we regenerate our map. So time offset equals 0. Great. Now we need to call it somewhere. So let's go to our map visualizer. Great. First of all, let's go down and find our clear map method. And here we are going to create if animation, if animate. So we need such a bool value up above here. We're going to create public bool animate. Let's slide it down. So if animate, we're going to call drop tween dot reset time. Great. Now, to make our cells drop with animation, we are going to go to create indicator, and we are going to set if animate. We are going to set element add component drop tween. So this will automatically on start add our animation to our game object, and we are going to say drop tween increase drop time to create this stairs effect when each next cell drops a little bit later. We can copy this code and paste it to our other create indicator method. So let's find it. Okay, here it is. So we can paste it here, and that's basically it. So let's save it. Let's go back to Unity. Okay, let's give Unity time to compile the scripts, and let's go to map visualizer, tick the animate, and let's see what happens. And we have this nice animation when we create our map, and we can go to map generator and generate our map, and you can see that it regenerates our map and also adds this animation. And we can uncheck the visualize using prefabs, and it will do the same thing with our obstacles with our raw view. So that's basically it for this part of the tutorial. So that's it for this video. In the next video, we are going to discuss the limitations of our map.